Hello everyone, my name is Dr. Ranganath Haridas. I am working as Assistant Professor in SVERI's College of Engineering, Pandharpur. Today we are discussing about one of the topic related to physics. Its name is elasticity, one of the point or syllabus related to CET preparation. So let us start the point elasticity, in which we are discussing or we are dividing our lecture into two parts. First is the basic terms and equations related to elasticity, and afterwards in the second half we are discussing and solving different numericals, of course, which is based on the terms and equations in elasticity chapter. So let us start from first slide only. We start with the title, that is elasticity. So you know that when we are considering the different material, so they have different properties, and this elasticity is one of the property of that material. So one by one we check first some basic definitions, and then we will go for the each and every term related to this elasticity of material. So let's start. We go for our second slide. So as I have told that basic terms and equations when we are considering for elasticity, so it is a property of material when we are considering that as material which is elastic, and you know that of course the opposite of that is plastic. If that particular body is having the elasticity property, then how we can consider the terms related to that? And of course if it is a plastic, means opposite to elastic material, then we have to check how it differs from the elastic. Okay, so let us start with the basic term, that is intermolecular force. So I read it first. So each and every slide we will discuss in English, and then I will explain that in Marathi also. So intermolecular force. So two terms are there. First is intermolecular force and second is deformation. So let us check first point, intermolecular force. In a solid, atoms and molecules are arranged in such a way that each molecule is acted upon by the forces due to the neighboring molecules. These forces are known as intermolecular forces. This is the first term. Let us define second also, that is deformation. So deformation is nothing but the phenomenon of change in shape or size of a body under the action of forces is called a deformation. Now let us check what is the exact meaning of these two terms. First is intermolecular force. It's simply in solid, these atoms molecules are arranged in such a way that they are acted upon by the forces due to each other, that is neighboring molecules, and these forces are nothing but called as intermolecular forces. Next is deformation, the phenomenon of change in shape or size of a body under the action of forces is called a deformation. Means there is a change in shape or size of body, of course by application of forces, and that deforms the body, and we are calling it as a deformation. So let us move to Marathi. इंटरमॉलिक्युलर फोर्स म्हणजे काय, तर थोडक्यात सॉलिड मटेरियल जे आहे तर त्याच्यामधले जे ॲटम्स आणि मॉलिक्युल्स आहेत तर त्यांची अरेंजमेंट जर आपण बघितली तर ते एकमेकावर फोर्स काय करत असतात, ऍक्ट करत असतात, आणि तो जो फोर्स आहे त्यालाच आपण काय म्हणतो तर इंटरमॉलिक्युलर फोर्स. दुसरी जी टर्म आहे ती म्हणजे डिफॉर्मेशन. डिफॉर्मेशन याचा अर्थ काय, थोडक्यात एक वस्तू जर आपण घेतली आणि त्याच्यावर जर आपण फोर्स अप्लाय केला तर काय होतं, तर त्याचा शेप आणि साईज जो आहे तर तो चेंज होतो. आपण काय म्हटलं इथं, चेंज इन शेप अँड और साइज ऑफ ए बॉडी. अंडर द ऍक्शन ऑफ फोर्सेस. म्हणजे त्या फोर्समुळे काय होतं, त्या वस्तूचा आकार जो आहे तर तो बदलतो आणि त्या प्रक्रियेला आपण काय म्हणतो, डिफॉर्मेशन. ओके, सो लेट अस मूव टू नेक्स्ट स्लाइड. In next slide, once again there are two terms. First is deforming force, and of course we start the definition or start with definition of elasticity. So let us read it first. Deforming force, the force applied to produce a change in size or a shape is called a deforming force. Means what? So just in our previous slide we have discussed what is meant by deformation. Okay, where we have already mentioned this force, but we are defining that force separately as the force applied to produce, means that force which produces changes in that particular shape and size of the body is called as deforming force, or the force which produces deformation is called as deforming force. Then next, now we move to the definition of elasticity. The property of the body to regain its original configuration, that is length, volume or shape, when the deforming forces are removed is called elasticity. The change in the shape or size of a body when external forces act on it is determined by the forces between its atoms or molecules. These short range atomic forces are called elastic forces. So let us check these two terms. First, as we have discussed what is meant by deforming force. Now in case of elasticity, the definition is the first few lines, that is 2-3 lines, and then how these intermolecular forces acting to form the elasticity we are checking. So once again I repeat the definition. Of course, the property of the body to regain its original configuration, means elasticity is the property of body which tries to regain its original shape or size. We can say configuration means length, volume or shape, etc., when the deforming forces are removed. Means, for example, if we are pressing a rubber ball and after removing the force, what happens? That ball regain its original shape. So it is nothing but elasticity. Now we will discuss this in Marathi. आपण आधीच्या स्लाइड मध्ये काय बघितलं, तर इंटरमॉलिक्युलर फोर्स म्हणजे काय आणि डिफॉर्मेशन म्हणजे काय. तर डिफॉर्मेशन याचा अर्थ काय, तर त्या पर्टिक्युलर बॉडीचा शेप आणि साइज जर चेंज होत असेल तर त्याला आपण डिफॉर्मेशन म्हणतो. पण तो कशामुळे होतो, तर डिफॉर्मिंग फोर्समुळे, जी डेफिनेशन आपण आता या स्लाइड मध्ये बघतोय. द फोर्स अप्लाइड टू प्रोड्यूस ए चेंज इन साइज ऑफ शेप. याचा अर्थ काय, तर तो जो फोर्स आहे ज्याच्यामुळे काय होतं, तर त्या पर्टिक्युलर बॉडीचा साइज किंवा शेप चेंज होतो, त्याला आपण डिफॉर्मिंग फोर्स म्हणतो. त्यानंतर आपण कुठली डेफिनेशन बघतोय, तर इलॅस्टिसिटी. आता इलॅस्टिसिटी म्हणजे काय, तर डेफिनेशन मध्ये काय सांगितलंय, द प्रॉपर्टी ऑफ द बॉडी, त्या बॉडीची ती प्रॉपर्टी काय करायची, टू रिगेन इट्स ओरिजिनल कॉन्फिगरेशन, म्हणजे परत त्याचा शेप आणि साइज आहे तर ती बॉडी मिळवायचा प्रयत्न करते. पण कधी, व्हेन द डिफॉर्मिंग फोर्सेस आर रिमूव्ड, म्हणजे त्याच्यावर आपण जो फोर्स अप्लाय केलाय तो जेव्हा आपण काढला तर त्यानंतर ती बॉडी काय करते, तर त्याचा ओरिजिनल शेप प्राप्त करण्याचा प्रयत्न करते. आणि ही जी प्रॉपर्टी याला आपण काय म्हणतो, इलॅस्टिसिटी. नेक्स्ट आपण वाचूया काय लिहिलंय, द चेंज इन द शेप और साइज ऑफ ए बॉडी व्हेन एक्सटर्नल फोर्सेस ऍक्ट ऑन इट is determined by the forces between its atoms or molecules. म्हणजे थोडक्यात काय, तर these short range atomic forces are called elastic forces. हे जे इलॅस्टिक फोर्सेस आहेत जे कशामुळे निर्माण झाले, तर ॲटम्स आणि मॉलिक्युल्स मधल्या फोर्समुळे, आणि त्यालाच आपण काय म्हणतोय, इलॅस्टिक फोर्स, आणि त्या प्रॉपर्टीला आपण म्हणतोय इलॅस्टिसिटी. Okay, so now we move to the next one. Next term is perfectly elastic body. Now we have checked out what is meant by elasticity, but now here we have added this term, that is perfect or perfectly elastic body. So let us check first perfectly elastic body, then plasticity, and then definition of stress. Perfectly elastic body means what? A body which regains its original configuration immediately and completely after the removal of deforming force from it is called a perfectly elastic body. For example, it is given quartz, phosphor, bronze are the example of nearly perfectly elastic bodies. Means what? Elasticity and elastic body we now discussing, but what is meant by perfectly elastic body? So there is a difference. Perfectly elastic body means a body which regains its original configuration immediately and completely after the removal of deforming force from it. Means naturally if we check, so there is no such a elastic body which is perfectly elastic. Here what we are adding, that quartz, phosphor, bronze are the example of nearly perfectly elastic bodies. It means that in nature there is no perfect elastic body, but as good as if we go close to perfection, we are taking names of these materials, which is quartz, phosphor and bronze. Then next is plasticity, which is opposite to elasticity. The inability of a body to return to its original size and shape even on a removal of the deforming force is called plasticity, and such a body is called as plastic body. What is the meaning of this? The inability of a body means that body is not able to return or regain its original shape and size if we remove the deforming force. So that body is called as plastic body, and that property is called as plasticity. Next term is stress. So let us define it first. Stress is defined as the ratio of the internal force, that is capital F, produced when the substance is deformed to the area capital A over which this force acts. In equilibrium, this force is equal in magnitude to the externally applied force. In other words, simply we are saying that stress is nothing but force upon capital A, that is area. So if we check the meaning of stress, so it is simply nothing but the ratio of the internal force produced when the substance is deformed, means when we are trying to deform that body, to the area over which this force acts. So that area we are considering in the denominator. So let us discuss in Marathi. Perfectly elastic body याचा अर्थ काय, तर निसर्गामध्ये अशी कुठलीच वस्तू नाहीये की जी परफेक्टली इलॅस्टिक आहे, की जिच्यावर जर आपण फोर्स अप्लाय केला तर ती आहे त्या शेप आणि साइज मध्ये परत येऊ शकते. पण त्यातल्या त्यात आपण क्वार्ट्स, फॉस्फर, ब्रॉन्झ अशी काही मटेरियल आहेत ज्यांना आपण परफेक्टली इलॅस्टिक म्हणतो, पण ते नियरली परफेक्टली इलॅस्टिक आहे. नेक्स्ट प्लास्टिसिटी. प्लास्टिसिटी म्हणजे इलॅस्टिसिटीच्या विरुद्ध, ज्याच्यात आपण काय म्हणतो, द इनएबिलिटी ऑफ ए बॉडी. म्हणजे ती जी बॉडी आहे तर ती परत तिचा ओरिजिनल साइज आणि शेप मिळवू शकत नाही. कधी? जेव्हा आपण तो फोर्स जो आहे तर तो फोर्स आपण काढून टाकतो. याला आपण काय म्हणतो, प्लास्टिसिटी त्या प्रॉपर्टीला. आणि अशा बॉडीज आहेत त्याला आपण म्हणतो प्लास्टिक बॉडी. आता आपण एक नवीन टर्म आहे ती म्हणजे स्ट्रेस. तर स्ट्रेस म्हणजे काय? स्ट्रेस इज डिफाइंड ॲज द रेशो ऑफ. स्ट्रेस काय तर रेशो आहे कशा कशाचा, तर इंटरनल फोर्स कॅपिटल एफ डिवाइडेड बाय एरिया ऑन विच दिस फोर्स ऍक्ट्स. म्हणजे तो जो इंटरनल फोर्स आहे तो न्यूमरेटर, डिनॉमिनेटर म्हणजे काय तर एरिया ज्याच्यावर तो ऍक्ट होतोय, तर त्याला आपण काय म्हणतो, स्ट्रेस. आणि स्ट्रेस जो आहे तर तो आपण सिंपली डिफाइन करतो, स्ट्रेस इज इक्वल टू कॅपिटल एफ अपॉन ए. ओके, सो नाउ let us go one by one to the next point, that is stress is of two types: normal stress, tangential stress. First, normal stress. It is defined as the restoring force per unit area perpendicular to the surface of the body. Normal stress is of two types: tensile stress and compressive stress. Tangential stress means what? When the elastic restoring force or deforming force acts parallel to the surface area, the stress is called as tangential stress. Means simply we are considering the force which is applied perpendicularly and parallelly, that are normal stress and tangential stress respectively. Next is strain. Now what is meant by strain? It is defined as the ratio of change in size or shape to the original size or shape. It has no dimensions, it is just a number. Once again I repeat, it is defined as the ratio of, means simply it is the ratio of change in size or shape to the original size or shape. Means for example, if we take length, so change in length divided by original length. So in this way we are defining the strain. So strain is of three types. First is longitudinal strain, then second is volumetric strain, and third is shear strain. So one by one we have to check these points. So now let us discuss these terms in Marathi. आपण चेक केलं की स्ट्रेस म्हणजे काय, तर फोर्स अपॉन एरिया, एरिया ज्याच्यावर तो फोर्स ऍक्ट होतोय. आणि त्या स्ट्रेसचे परत दोन प्रकार आहेत, नॉर्मल स्ट्रेस आणि टँजेन्शियल स्ट्रेस. एक आहे की तो जो फोर्स पर युनिट एरिया परपेंडिक्युलर असेल टू द सरफेस ऑफ द बॉडी, आणि दुसरा असेल पॅरलल टू द सरफेस ऑफ द सरफेस एरिया. तर त्याला नॉर्मल स्ट्रेस परपेंडिक्युलर साठी आणि टँजेन्शियल स्ट्रेस पॅरलल साठी म्हटलं जातं. पुढची टर्म आहे स्ट्रेन. आता स्ट्रेन म्हणजे काय, तर हा सुद्धा एक रेशो आहे. कशा कशाचा? इट इज द रेशो ऑफ चेंज इन साइज और शेप टू द ओरिजिनल साइज और शेप. म्हणजे एखादी जर बॉडी असेल तर त्याच्यामध्ये काय चेंज झाला आणि त्याची ओरिजिनल साइज किंवा शेप काय होता, याचा जो रेशो आहे त्याला आपण काय म्हणतो, स्ट्रेन म्हणतो. तर स्ट्रेन जे आहेत ते सुद्धा वेगवेगळ्या प्रकारचे आहेत. पहिला जो आहे तो लॉन्जिट्युडिनल स्ट्रेन आहे. त्यानंतर आपण दुसऱ्या स्लाइड मध्ये बघितलं व्हॉल्यूमेट्रिक स्ट्रेन आहे, आणि त्यानंतर पुढच्या स्लाइड मध्ये बघितलं शियर स्ट्रेन आहे. तर हे आपण आता प्रकार वन बाय वन चेक करूया. Strain is of three types. Longitudinal strain means what? If the deforming force produces a change in length alone, the strain produced in the body is called longitudinal strain or tensile strain. Okay, once again I repeat, if the deforming force produces a change in length alone means there is a change in length, then it is called as longitudinal strain. It is given by the equation longitudinal strain, which is equal to change in length, that is delta L, divided by original length L. If we see the figure, so in that we can check what is meant by L and L plus delta L. Of course we are stretching it, and due to stretching that strain happens and we are defining that thing. Then next is volumetric strain. If the deforming force produces a change in volume alone, the strain produced in the body is called the volumetric strain. It is given as simply volumetric strain, which is equal to change in volume delta V divided by original volume. So once again we can consider the change as volume alone. So in that case, if there is change in volume alone, then it becomes volumetric strain. Next, if we move to the third point, that is called as shear strain. The angle tilt caused in the body due to tangential stress expressed is called shear strain. It is given by, its equation is shear strain, which is equal to theta, which is simply delta L upon L. So we can consider our previous slide figure where we are getting the idea of that angle, that how this shear strain takes place. So once again I repeat that the angle tilt, that is theta, caused in the body due to tangential stress expressed is called as shear strain. So it is given by that theta, which is nothing but change in length divided by original length, or delta L upon L. The maximum stress to which the body can regain its original status on the removal of the deforming force is called its elastic limit. So it is another definition what is meant by elastic limit we are considering. Now we discuss these three terms in Marathi. आपण आता काय चेक करतोय तर स्ट्रेन म्हणजे काय, याचे तीन प्रकार आहेत. स्ट्रेन मध्ये लॉन्जिट्युडिनल स्ट्रेन पहिला, ज्यामध्ये आपण काय कन्सिडर केलं तर जेव्हा तो डिफॉर्मिंग फोर्स आहे तर तो काय प्रोड्यूस करतो तर चेंज इन लेंथ, म्हणजे जेव्हा लेंथ चेंज होते त्यावेळेस त्या स्ट्रेनला आपण म्हणतो लॉन्जिट्युडिनल स्ट्रेन, जे आपण इथे सांगितले लॉन्जिट्युडिनल स्ट्रेन विच इज इक्वल टू चेंज इन लेंथ अपॉन ओरिजिनल लेंथ. व्हॉल्यूमेट्रिक स्ट्रेन याचा अर्थ काय की ज्यामध्ये व्हॉल्यूम मध्ये बदल होतो त्याला आपण व्हॉल्यूमेट्रिक स्ट्रेन म्हणतो. त्यानंतर तिसरा प्रकार म्हणजे शियर स्ट्रेन, ज्यामध्ये काय सांगितले की द अँगल टिल्ट कॉज्ड इन द बॉडी ड्यू टू टँजेन्शियल स्ट्रेस. टँजेन्शियल स्ट्रेस म्हणजे ही जर फिगर आपण चेक केली तर इथून आपण काय करतोय, टँजेन्शियल स्ट्रेस जे आहे तर त्याच्यामुळे जे डिफॉर्मेशन होते तर ते शियर स्ट्रेनच्या अंडर आपण कन्सिडर करतो. आणि मॅक्सिमम इलास्टिक लिमिट जे आहे एखाद्या बॉडीचं तर ते काय आहे तर द मॅक्सिमम स्ट्रेस टू विच द बॉडी कॅन रिगेन इट्स ओरिजिनल स्टॅटस ऑन द रिमूव्हल ऑफ द डिफॉर्मिंग फोर्स इज कॉल्ड द इलास्टिक लिमिट. याचा अर्थ काय की एवढी स्ट्रेस आपण वापरायची की ती स्ट्रेस वापरल्यानंतर परत एकदा ती बॉडी तिचं शेप अँड साइज रिगेन करते किंवा परत प्राप्त करते, तर ते जे लिमिट आहे त्याला आपण काय म्हणतो इलास्टिक लिमिट. Okay, now we move to next point, that is Hooke's law. So Hooke's law states that within elastic limit, the ratio of stress to the corresponding strain produced is a constant, or they are proportional to each other. So this constant is called the modulus of elasticity, and we are representing that as a modulus of elasticity is equal to stress upon strain. Since strain is a pure number, the unit of the constant are the same, that is Newton per meter square. So this Hooke's law gives us idea about this modulus of elasticity. Then next we are moving to this modulus of elasticity, that is Young's modulus, bulk modulus, and modulus of rigidity. These three terms we have to check. So let us first discuss this in Marathi. Hooke's law म्हणजे काय तर सिम्पली स्ट्रेस इज डायरेक्टली प्रोपोर्शनल टू स्ट्रेन. Hooke's law states that काय स्टेट करतोय तर विदिन इलास्टिक लिमिट. आपण याच्या आधी बघितलं की इलास्टिक लिमिट म्हणजे काय, तर त्याच्यासाठी आपण आधी डेफिनेशन देतोय की विदिन इलास्टिक लिमिट, त्या इलास्टिक लिमिटच्या आतमध्येच हा Hooke's law काय होतोय तो व्हॅलिड आहे. सो विदिन इलास्टिक लिमिट्स the ratio of stress to the corresponding strain produced is a constant. This constant is called as modulus of elasticity. त्या कॉन्स्टंटला आपण काय म्हणतोय तर modulus of elasticity. So let us move to the next slide. First is Young's modulus. So for a solid in the form of a wire or a thin rod, Young's modulus of elasticity within elastic limit is defined as the ratio of longitudinal stress to longitudinal strain. It is given by Young's modulus, longitudinal stress that is F upon A. We have discussed the longitudinal strain that is delta L upon L, that is change in length upon original length. So if we adjust this term and put it properly, it becomes mgl divided by pi r square into change in length, that is delta L. We have mentioned its dimension and unit also. Next is bulk modulus. So what is bulk modulus? Within elastic limit, once again the bulk modulus is defined as the ratio of longitudinal stress and volumetric strain. It is given as, once again, longitudinal stress, that is F upon A, divided by volumetric strain, that is change in volume to the original volume that we have discussed already, So we can write this as P upon delta V divided by V, of course with the negative sign. And next one, that is the third one, which is called as shear modulus or modulus of rigidity. So it is defined as the ratio of the tangential stress to the shear strain, or this modulus of rigidity is given by simply tangential stress, that is F upon A, divided by shear strain, that is theta, that angle because of that tilt, which is called as shear strain. So let us discuss these points once again. आपण आता मॉड्युलस ऑफ इलॅस्टिसिटी बघतोय, ज्यामध्ये पहिला प्रकार आहे यंगचे मॉड्युलस, जो काय सांगतो तर यंगचे मॉड्युलस विद इन इलास्टिक लिमिट ऑफकोर्स आपण डिफाइन करतो. रेशो आहे तो कशा कशाचा, लॉन्जिट्युडिनल स्ट्रेस आणि लॉन्जिट्युडिनल स्ट्रेन. लॉन्जिट्युडिनल स्ट्रेस म्हणजे काय, फोर्स अपॉन एरिया. लॉन्जिट्युडिनल स्ट्रेन म्हणजे काय तर चेंज इन लेंथ अपॉन ओरिजिनल लेंथ. ऍडजस्ट केल्या टर्म आणि आपल्याला ही टर्म मिळते यंगचे मॉड्युलस, जी आपण न्यूमेरिकल्स मध्ये एमसीक्यू मध्ये वापरतो. बल्क मॉड्युलस जर बघितलं तर विदिन इलास्टिक लिमिट, वन्स अगेन इट इज डिफाइंड ॲज द रेशो ऑफ, रेशो आहे तो कशाचा, लॉन्जिट्युडिनल स्ट्रेस अँड व्हॉल्यूमेट्रिक स्ट्रेन. म्हणजे लॉन्जिट्युडिनल स्ट्रेस एफ अपॉन ए आणि व्हॉल्यूमेट्रिक स्ट्रेन म्हणजे चेंज इन व्हॉल्यूम डिवाइडेड बाय जे काय ओरिजिनल व्हॉल्यूम आहे त्याचा रेशो, तर त्याला आपण काय म्हणतो, बल्क मॉड्युलस. तिसरा जो प्रकार आहे मॉड्युलस ऑफ इलास्टिसिटीचा, तो म्हणजे मॉड्युलस ऑफ रिजिडिटी. इट इज डिफाइंड ॲज द रेशो ऑफ टँजेन्शियल स्ट्रेस टू शियर स्ट्रेन. टँजेन्शियल स्ट्रेस भागिले शियर स्ट्रेन जो रेशो होतो त्याला म्हणतो मॉड्युलस ऑफ रिजिडिटी. टँजेन्शियल स्ट्रेस आपल्याला माहिती एफ अपॉन ए, दॅट इज फोर्स अपॉन एरिया. शियर स्ट्रेन म्हणजे टिल्ट अँगल, दॅट इज थीटा, व्हिच इज कॉल्ड एज मॉड्युलस ऑफ रिजिडिटी. तर हे तीन प्रकार झाले मॉड्युलस ऑफ इलास्टिसिटीचे. देन we add few points, that is Poisson's ratio. The ratio of change in diameter, that is delta D, to the original diameter is called the lateral strain. The ratio of change in length to the original length is called the longitudinal strain. The ratio of lateral strain to the longitudinal strain is called the Poisson's ratio. याचा अर्थ काय तर आपण हे चेक करतोय की पॉइसन्स रेशो म्हणजे काय, तर हा कशा कशाचा रेशो आहे. सो इट इज रेशो ऑफ लॅटरल स्ट्रेन टू लॉन्जिट्युडिनल स्ट्रेन, दॅट इज चेंज इन डायमीटर टू द ओरिजिनल डायमीटर, चेंज इन लेंथ टू द ओरिजिनल लेंथ. सो इन केस ऑफ दिस पॉइसन्स रेशो we are giving this as the symbol, and if we go to the next one, then we are adding few more terms, that is relation between these elastic moduli, Young's modulus, bulk modulus, and modulus of rigidity plus Poisson's ratio. So if we consider the solved equations, so there are relations between these terms which are also useful once again for solving the MCQs or numericals. So first is y is equal to 3k bracket 1 minus 2 sigma. So in terms of Young's modulus, then these Poisson's ratio, we are defining that term. Then again one equation is there after solving, that is of Young's modulus. Then third is we are defining the Poisson's ratio in this modulus of elasticity, and next is the relation between yk and n. Next point is breaking stress. How we can define that? So the ultimate tensile strength of a material is the stress required to break a wire or a rod by pulling on it. The breaking stress of the material is the maximum stress which a material can withstand. Beyond this point, breakage occurs. So let us check these things. आपण काय डिस्कस केलं तर पॉइसॉन्स रेशो म्हणजे काय हे आपण बघितलं. तर तो कशा कशाचा रेशो आहे, लॅटरल स्ट्रेन आणि लॉन्जिट्युडिनल स्ट्रेनचा. त्यानंतर हे मॉड्युलस ऑफ इलास्टिसिटी आणि पॉइसॉन्स रेशो यांचे रिलेशन्स जे आहेत तर ते आपण डिफाइन केले. आणि ब्रेकिंग स्ट्रेस म्हणजे काय तर अशी स्ट्रेस की जिथपर्यंत ती बॉडी किंवा तो रॉड किंवा ते मटेरियल आहे तर ते इलास्टिक लिमिट मध्ये काय करू शकतं, सहन करू शकतं, दॅट इज दॅट मटेरियल कॅन विथस्टँड. बियॉन्ड दिस पॉइंट म्हणजे त्या पॉइंटच्या पुढे जर आपण त्याला काय करत गेलो तर स्ट्रेच करत गेलो, so beyond this point breakage occurs. Okay, so we have added this term also. So related to breaking stress also some equations are there. So this work done per unit volume of a wire is given as we have directly written these terms. There are different steps, so we are using that terms in the MCQ also. Now this is, we can say, first part, and in that first part if we check, so in that first part we have discussed some basic terms. Now we are moving towards numerical solving. So basic terms: intermolecular force, deformation, deforming force, definition of elasticity, then perfectly elastic body, which is not present in nature but nearly perfect. We are defining some terms: plasticity, definition of stress, its equation, then types of stress, strain, types of strain, then Hooke's law, then the different modulus, that is Young's modulus, bulk modulus, modulus of rigidity, Poisson's ratio, relation between these YKN and Poisson's ratio, and last is breaking stress. तर हे पॉइंट्स आपण डिस्कस केले. Now we move to the MCQ options. What is the answer and why? The answer is that, or why that answer comes where we are checking the solutions step by step. So let's start with the first MCQ. I read it and then we will check the solving steps. वन बाय वन आपण हे डिस्कस करूया आणि हा जो सेकंड हाफ आहे तर तो आपण कंप्लीट करूया. फर्स्ट MCQ: the force required to punch a hole of diameter 2 mm will be, in bracket given thing is, if a shearing stress is 4 into 10 raised to 8 Newton per meter square. The force means we have to calculate the force. The force required to punch a hole of a diameter 2 mm will be. So this value is given to us, which is diameter. Of course we have to use that value as given value, and shearing stress is also given, that is 4 into 10 raised to 8 Newton per meter square. Now options are there, answers also I have written, but how that answer comes? So solution, for that we have to know this equation, that is stress is equal to F upon A. Now we have to determine force. So simply force is equal to stress into pi r square. Now here shearing stress is given, that is 4 into 10 raised to 8 pi into r square. So from diameter we can determine the radius, and after calculation simply we are getting the answer, that is F is equal to 400 pi Newton, which is one of the option for MCQ. आपण इथे काय डिस्कस केलं तर MCQ मध्ये प्रॉब्लेम किंवा क्वेश्चन काय, द फोर्स रिक्वायर्ड टू पंच अ होल. आपल्याला फोर्स रिक्वायर्ड म्हणजे कॅपिटल F ची व्हॅल्यू काढायची, टू पंच अ होल ऑफ डायमीटर, डायमीटर दिलेला आहे 2 mm, आणि शेअरिंग स्ट्रेस ची व्हॅल्यू आपल्याला दिलेली. स्ट्रेसचा फॉर्म्युला आपल्याला माहिती, स्ट्रेस इज इक्वल टू F अपॉन A. F ची व्हॅल्यू आपल्याला काढायची, स्ट्रेस ची व्हॅल्यू इनटू एरिया बाय r स्क्वेअर, डायमीटर दिला त्याच्यावरून रेडियस ची व्हॅल्यू आपण घेतली आणि ती व्हॅल्यू आपण टाकली की आपल्याला काय मिळते, आन्सर. ओके, सो इट इज अ सिंपल MCQ. नाउ वी चेक द नेक्स्ट वन. सो I read it first. What will be the greatest length of a steel wire which when fixed at one end can hang freely without breaking? So here we have to determine the greatest length, that is capital L. So what will be the greatest length of a steel wire? Steel wire we have considered which when fixed at one end can hang freely without breaking. So this condition also we have to consider, that is breaking stress value of steel is given to us and the density is also with us. So if we check the options, answer is B, but how it comes? So for that we have to know the term what is meant by breaking stress, that is L rho G. We have to determine L, so breaking stress divided by rho into G. The values are with us. So if we put the value, breaking stress value is 7.8 into 10 raised to 8, and the value for rho steel, that is 7.8 into 10 raised to 3 into value of G if we put, so we got the answer. So for that we have to know the breaking stress is nothing but L into rho into G. हे डिस्कस करूया आपण आता. व्हॉट विल बी द ग्रेटेस्ट लेंथ ऑफ ए स्टील वायर. ग्रेटेस्ट लेंथ जी आहे म्हणजे लेंथ आपल्याला काढायची कशाची, स्टील वायरची, which when fixed at one end, एका एंडला आपण फिक्स केलंय आणि तिला हँग केलंय फ्रीली विदाउट ब्रेकिंग. म्हणजे ब्रेकिंग स्ट्रेस ची व्हॅल्यू आपल्याला दिलेली आहे. त्याच्यावरून आपण काय केलं तर ब्रेकिंग स्ट्रेसचे इक्वेशन वापरलं. ब्रेकिंग स्ट्रेसचे इक्वेशन वापरून त्यात गिवन व्हॅल्यूज टाकल्या आणि आपल्याला आपलं उत्तर मिळालं. So that is the second one. Now we move to the third. I will read. The greatest length of a steel wire that can hang without breaking is 10 km. So without breaking, that wire can hang up to 10 km if the breaking stress for steel is, so the value is given here, so it is actually 10 raised to 8, 8.25 into 10 raised to 8 Newton per meter square. Then the density of the steel is, so density of the steel we have to determine. Value of G is purposefully given to us, that is 10 meter per second square. So we have to now check the things. So breaking stress we know, that is L into rho into G. So rho we have to determine. Breaking stress value is given to us, divided by L into G. Values are with us, we are putting the value, and the answer we are getting is 8250 kilogram per meter cube. इथे आपण काय चेक करतोय तर द ग्रेटेस्ट लेंथ ऑफ द स्टील वायर, एका स्टील वायरची ग्रेटेस्ट लेंथ आहे जी आपण हँग केली विदाउट ब्रेकिंग, म्हणजे ब्रेक न होता ती 10 किलोमीटर पर्यंत त्याची लेंथ आहे. इफ द ब्रेकिंग स्ट्रेस फॉर स्टील इज, ती जी व्हॅल्यू आहे ब्रेकिंग स्ट्रेसची ती व्हॅल्यू दिलेली आहे 8.25 into 10 raised to 8 न्यूटन पर मीटर स्क्वेअर. तर त्याची डेन्सिटी जी आहे तर ती आपल्याला डिटरमाइन करायची, जीची व्हॅल्यू आपल्याला पर्पजफुली दिलेली आहे. आणि आपण या व्हॅल्यूज ब्रेकिंग स्ट्रेसच्या इक्वेशन मध्ये जर पुट केल्या तर आपल्याला याचा आन्सर मिळते, जे आहे 8250 किलोग्राम पर मीटर क्यूब. ओके, सो वी मूव टू द नेक्स्ट एमसीक्यू. Next MCQ is the length of a wire increases by 1% on loading 2 kg weight on it. The linear strain in the wire is. So options are there. For that we have to know what is meant by strain, that is change in length divided by original length. Now here what is given, that strain we are considering, which is change in length upon original length. So the length of a wire increases by 1%. So 1% and 100% if we compare, so 1% is nothing but 0.01 and 100% is 1. So simply we are taking its ratio, we are getting the answer as 0.01. या MCQ मध्ये काय आहे तर the length of a wire increases. तर आपण लोड जर वापरला 2 किलोग्राम वेटचा तर ती जी लेंथ आहे त्या वायरची तर ती 1% वाढते. तर त्याची लिनियर स्ट्रेन काय आहे हे विचारले, तर याच्यासाठी आपल्याला इक्वेशन माहिती पाहिजे. इक्वेशन तर सिंपल आहे पण इथे लॉजिक आहे की इन्क्रीजेस बाय 1%. याच्यावरून आपल्याला हे लक्षात आलं पाहिजे की या व्हॅल्यूज आपल्याला काय घेतले पाहिजे. जर इथे 10% असतं तर हे 0.1 डिवाइडेड बाय 1 असं आलं असतं. हे 1% आहे त्यामुळे 0.012 डिवाइडेड बाय 1 means 0.01 is the answer. Then move to the next one. A breaking force for a given wire is capital F. The breaking force for the wire having double the thickness is. Now here it is a MCQ, it is a numerical without any numerical value. So options are given, answer is in front of you. So we know the formula, that is Young's modulus. From that we have just modified this formula, that is for F, because we have to determine the breaking force. So F is equal to YAL divided by capital L. But as numerical value is missing, but we can use the logic as a breaking force for a given wire is F. The breaking force for the wire having double the thickness is. Double the thickness means we have to consider the area, that is pi r square. So here what happens here, it is double, but the relation between F and this area means radius is F is proportional to r square. So here that answer becomes 4F. As it is double, so it becomes square and it simply becomes 4 into the F, that is force. याच्यामध्ये या MCQ मध्ये काय दिले, breaking force for a given wire is capital F. The breaking force for the wire having double the thickness is. म्हणजे काय, तर थिकनेस डबल झाला त्या वायरचा, वायर आपण गोल कन्सिडर करतोय आणि याच्यामध्ये आपण काय करतोय, तर एमचं मॉड्युलस जे इक्वेशन वापरलं त्यामध्ये आपण इक्वेशन ऍडजस्ट केलं. फोर्स इज इक्वल टू YAL डिवाइडेड बाय कॅपिटल L, म्हणजे चेंज इन लेंथ आपण ओरिजिनल लेंथ. आता यामध्ये आपल्याला हे माहिती की फोर्स आणि रेडियस मधलं रिलेशन काय, तर फोर्स इज डायरेक्टली प्रोपोर्शनल टू स्क्वेअर ऑफ रेडियस, कारण का एरिया मध्ये पाय आर स्क्वेअर, दॅट इज आर स्क्वेअर इज देअर आणि त्यामुळं याचा स्क्वेअर असल्यामुळं डबल आहे, सो इट बिकम्स सिंपली 4F. Move to the next MCQ. Next is the breaking force of the wire is 10⁴ Newton and the radius is 1 into 10⁻³ meter. If the radius is 2 into 10⁻³ meter, then the breaking force will be. Now here the radius changes, so we have to know what happens if radius changes. For that we have to compare these two things, that is F1 R1 and F2 R2. So we are taking the ratio simply that F2 upon F1, as we know that it is proportional to R square. So F2 upon F1 is nothing but R2 upon R1, its square. So F2 upon F1 is nothing but value of R2, that is 2 into 10⁻³, value of R1 1 into 10⁻³ its square. So simply it is a 4, or F2 is nothing but 4 into, we have shifted this F1 here, 4 into F1, and the value of F1 is 10⁴ Newton. So simply F2 is nothing but 4 into 10⁴ Newton, which is option A, which is correct. तर या MCQ मध्ये आपण काय चेक करतोय, तर the breaking force of a wire is, वायरचा ब्रेकिंग फोर्स दिलेला 10⁴ न्यूटन आहे and the radius, त्याची रेडियस दिलेली 1 into 10⁻³ मीटर. जर रेडियस 2 into 10⁻³ मीटर असेल तर ब्रेकिंग फोर्स किती असेल. यासाठी आपण काय केलं, तर आपल्याला फोर्स आणि रेडियस मधलं रिलेशन माहिती आताच आपण बघितलेले, तर त्या दोन्ही फोर्सचा रेशियो घेतला, तसंच रेडियसचा पण रेशियो येणार, त्याचा स्क्वेअर येणार. रेडियसच्या व्हॅल्यूज आपल्याला माहिती आहेत, त्या व्हॅल्यूज आपण टाकल्या, ते सॉल्व केलं आणि लेफ्ट हँड साइड LHS चा जो डिनॉमिनेटर आहे तो RHS ला शिफ्ट केला. F2 इज इक्वल टू 4 into F1. F1 म्हणजे काय, तर द ब्रेकिंग फोर्स, जिची व्हॅल्यू आपल्याला माहिती जी आहे 10⁴ न्यूटन, ती व्हॅल्यू टाकली आणि आपल्याला आपला आन्सर मिळाला. ओके, सो नाउ वी मूव टू नेक्स्ट वन. Number 7. A metal wire can be broken by applying a load of 45 kg weight. Then the force required to break the wire of twice the diameter for the same material is. Okay, so here we have to consider once again the same type, but just the MCQ is different. Metal wire can be broken by applying a load of 45 kg weight. Now the force required to break the wire of twice the diameter for the same material is. So diameter is twice. So for that, once again we are using the same thing, same equation. We know the value of F1 and after multiplication we can get this. So if we check these MCQs, the solution pattern or equation is same, but the language is different. So just we have to consider these MCQs and use the same equation for solving. Now let us move to the next one. A cable breaks if stretched by more than 2 mm. It is cut into 2 equal parts. By how much either part can be stretched without breaking? Once again I repeat, a cable breaks means that cable breaks if we are stretching it more than 2 mm. It is cut into two equal parts. We have cut that cable into two parts, of course equal parts, by how much either part can be stretched without breaking. So without breaking, that one of the part how we can stretch. So for that we have to consider the concept or basic terms as L is directly proportional to L, means the change in length is directly proportional to original length. So we are considering here as L1 upon L, which is equal to L by 2 upon L, which is equal to 1/2. So we have taken the ratio of two conditions. First condition is the original length, that is 2 mm, and its a change in length, that is L. Next condition is we have considered two equal parts. We have cut that wire into two equal parts. So that two equal parts means it becomes L by 2. Change in length, that is L1, is related to original length, that is L by 2. So we have simply got the ratio, that is 1/2. So L1 upon L, which is equal to 1/2. If we put that values, then we can get L1 is equal to L by 2, which is equal to 2 by 2 or simply 1 mm. So here we can get the answer as 1 mm. Okay. Next, if a wire is compressed to half of its length, then the strain will be. So here strain, we know the equation, change in length upon original length, as L is equal to L by 2, means if a wire is compressed to half of its length, then the strain will be. So we are compressed to half means that small l is nothing but L by 2. So L by 2 upon L, that is 1/2, that is simply 0.5. It is a simple one. And then we move to the 10th MCQ, that is last one. The Young's modulus of a material is 10⁻11 Newton per meter square and its Poisson ratio is 0.2. The modulus of rigidity of the material is. So we have considered the values, and from that we are calculating that the given things. So from given things we are calculating the things. So I think we have covered these terms or these MCQs. So from the first, if you consider, so basic terms we have discussed, and then we have discussed some of the numericals which are not that much difficult, they are simple one. Now thing is that you have to know and understand that how we can apply that concepts, apply that points to solve that numericals. So it's better to understand the concepts one by one, and then we can get the idea that how we can solve the MCQs or numericals. So from the first point, if we check, so we have started with these basic terms: intermolecular force, forces between atoms and molecules, then deformation, that is change in size and shape of a body, then it is due to this deforming force. Elastic property of the body, perfectly elastic means what? Elasticity property. What is meant by stress? It's a type. Strain, it's a type. Then Hooke's law, then Young's modulus, bulk modulus, modulus of rigidity, then Poisson's ratio, relation between these elastic moduli, and then we have solved different numericals. So I think we have covered some of the basic terms and points related to elasticity. So we conclude our lecture here. Thank you very much for listening and watching this lecture.